Hi everyone, this is the Lesson 8 Extra Practice ECON315 Guided Study Group session for this week. So the 4 problems we're going over today are pretty long. They're a lot different than what we've been doing because you've recently been introduced to net present value, which is a lot different than equilibrium and graphing and the conceptual stuff we've done. So these 4 really just focus on net present value, and the big idea with net present value is we're going to take a job or invest in something if the net present value of something is greater than 0, but if it's less than 0, meaning it's negative, then we're not going to accept that job or invest in something. So I'm going to get started right with number 1. So investing in school. Consider an individual who lives for 2 periods. In the first period, the individual might either work or go to school, but not both. In the second period, the individual will work regardless of what was done in the first period. If the individual forgoes schooling and decides to work, she will earn $200 in period 1 and $250 in period 2. If she decides to get an education in the first period, her wage in period 2 will be $575. The direct cost of schooling in period 1 is $100. So number 1, if the individual's discount rate is 10%, will she work or go to school in the first period if her utility is a function of income only? So since her utility is a function of income only, we're just going to compare the two of either going to work or school in the first period and see which net present value comes out greater. So of course they gave us a lot of information, so I think the easiest way to keep track of all of this is making a table. So let me switch over. Okay, so I'm going to write out period 1 and period 2. Now in this case, period 1 is her initial period, and then period 2 would be the first year. So period 1 is initial, so currently, and then period 2 is year 1. So once we look at this net present value equation, we're going to see that we don't discount the first value, but I'll keep writing this information out. So we have both periods, and then we have work, and we have school. So in period 1, if she decides to work, she'll make $200, and then in period 2, she'll make $250. If she goes to school, she'll lose $100 in the first period because that's her cost of schooling. And then in the second period, she'll make $575. And then they told us the discount rate was 10%. So this is going to translate to our R value equaling 0.10. So this present value equation that we need to solve this problem, it's going to be present value equals future value over 1 plus R to the T. So PV is present value, FV is future value. In these problems, a lot of the times the future value is just going to be their earnings or their incremental earnings. In this case, what we're looking at is their actual wage that they're making for this problem, but you'll see what I mean in other problems. And then R is the discount rate and T is time. So what we see is, for this problem, what we have to do is take the net present value. So net present value means it's just the summation of all the benefits and costs. So we just have to take this present value equation for each period and then sum them all up. Net present value is just like a summation of multiple present value equations. Hopefully that makes sense. Some people get confused with what's meant by net, so I wanted to explain that. You have to use this equation multiple times, like once per period. But if you're using multiple periods, you're going to have to use it multiple times and then sum them or add them all together. So anyway, I'm going to look at the work side first and find the net present value of that. So the net present value is going to equal 200. So we're looking at the first period, and we just use this equation. So the future value over 1 plus the discount rate, which is 0.1 to the t. Now in this case, because period 1 is our initial year, meaning currently, time is going to be 0. So with that, this entire denominator turns into 1, so we're just left with 200. Just wanted to show that. So then that was the first time we used the present value equation. And now we have to factor in the second period, so that's going to be 250 over 1 plus 0.01 to the first power, because in this case period 2 is year 1, so our t is 1. For figuring out these periods and years, you really have to pay attention to the wording of the problem. Usually if we don't discount something, they make a point to say it's like the first period or living currently or it's your initial year. If we do have to discount everything, like even the first year, it usually says starting next year or for the next 2 years, or it usually makes a hint of it in the problem. So really pay attention to the wording. But after that, side note, so this is the only equation, this is our full equation because we only had 2 periods. So we had the first period that wasn't discounted since it was our initial year, and then the second period discounted because it was year 1. So then we can just do the algebra for that, and we see that the net present value is going to equal $427. And that is all that was needed for this one, for the work side. But now we have to do the school side because they wanted us to compare them and then see which one was the better choice, investment, however you want to phrase it. So in this case, the net present value is going to be, the initial period that isn't discounted is negative 100, since it's a cost, and then we add in the discounted second period, or year 1, which is 575 over 1.1 raised to the first power. So then simplifying that, we get a net present value equal to $423. So as I said at the beginning, because utility is a function of income only, they're going to go with the choice that gives them a higher income. So after doing this problem, we see that that is going to work for this person. So this individual will go to work. They'll go to work in the first period. Hopefully you understood what I meant there. But that was all of number 1, just a really simple start to these net present value problems. Hopefully you're able to follow along. But like I said, I think one of the most important things is paying attention to the wording of the problem to figure out if the first term in your equation needs to be discounted or not. So I can move on to number 2. So number 2 is selecting a job. So a worker is offered a job at 2 different firms. At the first firm, the wage paid increases each year. At the second firm, the wage is constant over time. The worker anticipates working 3 years at whichever job she accepts and then retiring. The first firm offers a 3-year contract paying an annual salary of $50,000 in year 1, $60,000 in year 2, and $70,000 in year 3. So number 1 says if the worker's discount rate is 0.1, 10%, what must the annual salary be at the second firm for the worker to accept its job offer? So again, a lot of information. So sorry. This is for number 2. So I'm going to start out by writing everything down. So firm 1, they have a wage increase each year. So year 1 is 50,000. Year 2 is 60,000. And year 3 is 70,000. And then firm 2, the wage is constant. So they said the discount rate was 0.1, and they wanted to know what the annual salary at firm 2 would be for the worker to accept the offer. So now what we have to look at is the incremental earnings, so the difference of earnings between the 2 places. So what we want to know is what does the difference of earnings need to be to make the net present value greater than 0? Because when that difference of earnings is greater than 0, we can see that it's a better investment to take the job at the second firm where the wage is constant. So another important thing looking at these problems is how to set them up. So the net present value is going to be each year. You have to take that present value, I'll write the present value equation off to the side. Present value equals future value over 1 plus r to the t. So we have to take this present value equation for each period and then sum them all together. So for the first year, we can see that the first firm had a wage of $50,000 and the second firm had a constant wage. I'm going to denote that constant wage is equal to X. So the difference of earnings, that is, in this case, our future value, would be X minus 50,000. That would be our difference of earnings. Whatever they're making at firm 2 subtracted from 50,000. That'd be the difference in earnings, and that's the future value term for equation. And we put that over 1.01 to the first power, because this time the first period is discounted because we're talking about them taking a job in the future. They're not deciding about this job currently and starting right away. They're talking about they're going to take this job and then they're going to pay like this much in year 1, this much in year 2, etc. So that's why this first period is discounted this time. So then we can do the same exact thing for the second term in the equation, which is the second year. So again, the difference of earnings of X minus 60,000 over 1.01 squared, because T is going to equal 2 now since it's the second year. And again, I skipped the part of adding 1 with the discount rate, but that's how I got this 1.01. It was 1 plus 0.1. And finally, we can do the third year, which is X minus 70,000 to get that incremental earning or difference of earnings. And then it would be 1.01 cubed since it's the third year. And again, we want this to be greater than 0. So now all we have to do is solve for x to figure out, because essentially what we're doing is we can not pretend. What we can do is look at this equation as being equal to 0 and then solve for 0. We know whatever answer we get, that's the minimum for what it needs to be, the constant wage needs to be. So now since we've set it to 0, it can look a little easier to see that we need to solve it. So I think the easiest way to solve this is to take the entire thing and multiply it by 1.10 cubed, because that's going to get rid of all the fractions. So we have to apply this multiplication to each term. So 1.01 cubed multiplied by this first term is going to be, we still have x minus 50,000. And now we have 1.01 squared, because this term that I multiplied it by is in the numerator, and dealing with exponents, dividing by exponents, you just subtract the powers. So it would, 1.01 cubed over 1.10 to the first power just becomes 3 minus 1, so 1.01, or 1.10 squared. But anyway, that simplifies into this term. And then we do the same thing for the last two. So the next term is going to be x minus 60,000 times 1.10, because 3 minus 2 is 1, so this is just raised to the first power. And then the last one is just going to be x minus 70,000, because the numerator and denominator perfectly cancel out. And then again, we can just set this equal to 0. So then multiplying all of this out, we have the 1.1 squared becomes 1.21, and then I distribute that to each term it's being multiplied by. So this becomes 1.21x minus 60,500 plus 1.01x minus 66,000. Because now we've moved on to this part, and 1.01 just stays 1.01. So this gets distributed there and there. And then we can add in this last term, which is just plus x, and then minus 70,000. So then combining all these terms, we get 3.31x minus 196,500 equals 0. And now we can see it's a lot easier to solve for 0 after simplifying all this down. So we can add the constant term to the side to get 3.31x equals 196,500. And then dividing by 3.31 on both sides, we get an x equal to 59,365.56. So what this number is it tells us the minimum salary the second firm needs to offer to make the worker choose to work there rather than firm 1. And that was all that was needed for this in part 1. We just found the constant salary firm 2 needed. And then part 2 says, how does the lowest annual salary that must be paid by the second firm in order to attract the worker compare to the average annual salary paid under the 3-year contract offered by the first firm? So all we have to do is find the average annual salary for the first firm and then compare it. So finding the average for the first firm, we can just add up the three numbers and then divide by 3. So 50,000, 60,000, 70,000. Excuse me. 70,000. All of that added together gives us 180,000. And then we can divide that by 3. So we see that the average wage, or the average annual salary for the first firm, is 60,000. And we can see, comparing it to this one, that the average annual salary in firm 1 is greater than the constant wage offered in firm 2. But even with this comparison, we found through our net present value equation that it's more worthwhile for the person to accept the job at firm 2 if they offer this minimum of $59,365. So that was interesting, though, to compare both them. But I think that is all of number 2, so we can move on to 3. So number 3, graphically investing in school. So suppose that the marginal cost of an additional unit of human capital is given by marginal cost equals 400. The marginal benefit is given by marginal benefit equals 800 minus 25 HC, where HC is the number of units of human capital. Number 1, graph MB and MC as a function of HC. So now we're getting into more graphing, obviously. So for this is number 3. So part 1 says, well, first, our given information is that the marginal cost equals 400, and then the marginal benefit equals 800 minus 25 HC. So part 1 says, graph MB and MC as a function of HC. So we can draw our XY plane and label it as, they wanted us to graph MB and MC as a function of HC. So this means that MB and MC are going to be on our y-axis and HC is going to be on our x-axis. So graphing the first equation, MC equals 400. That's just going to be a straight line, horizontal line at MC equals 400. Because since HC isn't factored into the equation, we know that it's going to be 400 no matter what HC is. And then looking at our second equation, I like finding the intercepts first. So we can see that when HC is 0, MB is going to be 800. And then when MB is 0, HC is going to equal 32. I think I've said this in past videos. I think just putting zeros in is the easiest way to solve the intercepts. So that's all we needed, almost all we needed for the graphs. We should probably label them. So MC and MB. And now those graphs are complete. So that was all that was needed for number 1. Graph MB and MC as a function of HC. So then it says calculate the optimal level of human capital investment HC. So we know that the optimal level is going to be where marginal cost equals marginal benefit. So obviously looking at a graph, it's going to be where these two lines intersect. And the only way in this problem we can solve for that is just setting these two equations equal to each other. So we still have a little bit of equilibrium. So 400 equals 800 minus 25 HC, not equilibrium, just solving equations. So then we can subtract 400 from each side to get 400 on the right, and then add 25 HC to get 25 HC on the left. And then dividing each side by 25 HC, we see the optimal level of human capital is going to be 16. So that was 2. And then 3 says, the growing importance of computer skills in today's economy leads firms to place a greater premium on human capital investment. As a result, the marginal benefit of an additional unit of human capital increases to marginal benefit equals 800 minus 20 HC. Answer parts 1 and 2 again, given this change in the value of human capital investment. So again, solving for this graphically. We have marginal benefit, marginal cost, human capital. Our marginal cost line did not change, so that still remains at 400. I did not make that very straight, but hopefully you get the idea. So changing this equation is going to change our intercepts a little bit. So HC, when HC is 0, we still have the MBMC intercept as 800, but now the the HC intercept is going to change. So MB equaling 0 is going to make HC 30. Nope, it's going to make it 40. So if I were to graph these to scale and put both of these on the same graph, what we would see is that this second graph, the slope is going to be a little bit flatter than the first one. So, and we can see that with this intercept, really keeping this MC intercept constant, we kind of just rotated this line counterclockwise out a little bit. So if they were put on the same graph, you would see the slopes are different. But then we can label these two lines, MB, MC. And then again, we just have to find our optimal level. So we now have 400 equals 800 minus 20 HC. So 20 HC on the left equals 400 on the right. So we can see that HC is now 20. And that was everything for number 3, so we just have one problem left. So Billy and Bob are both 50 years old and work at the same firm. Billy is a more able individual and presently earns $90,000 a year. Bob earns $50,000 a year. They have the opportunity to enroll in a job training course for a one-time cost of $10,000. The raise to which they are entitled depends on how much they learn in the course. Again, since Billy is more able, he expects to earn an additional $2,000 a year, while Bob expects to earn only an additional $1,000 a year. both workers have a discount rate of 5%. So if both workers expect to work until age 60, so 10 more years, will either opt to take the course. So this goes back to net present value. What we have to find for each person is the net present value of this course and its potential earnings, and then see if it's greater than 0 and if they should take it or not. So Billy earns $90,000 a year. And Bob earns $50,000 a year. And for both of them, the cost of the program is $10,000. So from taking this course, they would expect to earn, which in this case are incremental earnings, for Billy would be $2,000 a year, and for Bob, $1,000 a year. And then for both of them, the discount rate is 0.05%. So again, we're looking at whether they should take the course or not, because they each expect to work 10 more years. So in this case, with them expecting to work 10 more years, we are going to discount the first year. And I'm going to start with Billy. So again, the net present value is just the summation of the present values for each of the 10 years. So net present value equals. So his initial costs are $10,000, so that needs to be subtracted from the equation because net present value is a summation of the costs and benefits. So his initial cost, his current cost, would be $10,000, and those will not be discounted. And then we can look at the benefits from this. So he would earn $2,000 each year, and then that $2,000 needs to be discounted for each year. The $2,000 would be the future value portion of the present value equation. And since that $2,000 is the same for all 10 periods, I'm going to start this off by factoring that out of the top. And you'll see why later it'll make it easier to calculate this and the next one. So factoring out this $2,000, what we can do is it leaves 1 over 1.05, because that was the 1 plus r portion, raised to the first power. And then we can do the same thing for 1.05 raised to the second power, 1 over 1.05 third power. And you keep doing this until you get t equals 10. So I don't have enough room for that, so I'm gonna cap it off there. So with this equation, the way I've set it up is I factored out the incremental earnings for each period to make it easier to calculate this big long portion at the end. So negative 10,000 plus 2,000 times the quantity of. So plugging this into your calculator, 1 over 1.05, you get 0.952. And then you can just divide that again by 1.05 to get the second value of 0.907. Don't clear anything, keep dividing by 1.05 to get each term. So the third one would be 0.864. And you keep doing that until you get it 10 times. Just focus on what numbers you're plugging into your calculator. I'll write everything I got down here so you can check your work, but I got 0.952, 0.907, 0.864, 0.832, 0.784, 0.746, 0.711, 0.677, 0.645, and finally 0.614. And that is all 10 of them. And then we can add each of those decimals together, and I get a value of 7.723. And then this is a lot easier to simplify out. So this becomes negative 10,000 plus 15,446, which comes out to a positive 5,446. So what we can see from this is, since it's a positive, the net present value is positive, Billy should take the course. And then we do the same exact thing for Bob. So the equation is going to be set up the same. Net present value equals negative 10,000. This time his incremental earnings are only $1,000. And then it's also set up the same way. I did the same thing of factoring out the 1,000 to leave just this big long decimal. Or this, each of these present value equations are only left as 1 over whatever the discount factor is. So now the easy thing is we already calculated that big long portion that was left over from factoring out the incremental earnings, the 7.723. So I can just sub that in here and not possibly make another math error. So this equation simplifies to negative 10,000 plus 7,723, which equals negative 2,277. So what we can see from Bob's situation is that his net present value is negative. So if he would take the course and have this potential earnings, but since his net present value is negative, he should reject the training course and not take it. So we can see there was 2 outcomes for the 2 men. And that was all we had to figure out for part 1. So a lot of math, but I think factoring out the $2,000 at the beginning makes it a little easier. So for part 2, it says, what is the minimum number of years each worker needs to work before retiring if the course is to be a wise investment? So now they want us to know the actual amount of years. What we found out already is that for Billy, his T term is going to be less than 10 years because his net present value is positive after the 10 years. So that meant that his incremental earnings covered the cost of the program in 10 years or less. What this problem wants us to do is find the minimum amount of years needed to cover that cost. And then for Bob, because his net present value was negative, we know that his incremental earnings from the training course did not fully cover the cost of it. So his t-value is going to be somewhere greater than 10 years. And now we have to figure out these t-values. So for Billy, I think really the only way I found of solving this is step by step. So you take the first period, 2,000 over 1.05, and you get that value, which is 1,904. And then you add on second period, and the third period. I'm going to do a couple down the line just to write it out. We do know, though, that this minimum has to be 10 years or less. So we should hit the 10,000 mark before we reach 11 periods. So we have 1904, and then 1814, 1728, 1645. If you want to take if you want to give yourself some kind of guess, these are all about 2,000. They each get just kind of more and more, but we know to cover $10,000, that's going to be about 5 years or more. It would have to be at least 5 years, 5 periods, since we're discounting it. So I think that's a good way to maybe to give yourselves an estimate. So 1.05, and then 1.06. So these two come out to 1567 and 1492. So add it up as you go along. So adding these 6 up, we can see that it equals 10,150. So with just the first 5 periods, we would see that it's less than 10,000, and adding that 6th period reaches that 10,000 mark. So what this means is that it takes Billy at a minimum 6 years to cover the cost of the program. So if he was only looking to do the bare minimum just to cover the cost of the training program, then he should only work 6 years. And then we do the same exact thing for Bob, but we know for Bob's case, he's going to be in a range somewhere greater than 10 years. So we would have this time 1,000 in the numerator, and then 1.05. Squared. So we know we would have to write out at least all these terms at least to the 10th power. So we have 952 plus 907 plus 864 plus 823. And then we keep going and going and going and adding them up like we did for Billy. And what we'll get after we keep adding stuff on and looking at it piece by piece, we'll see that after 15 periods, he'll reach a total of 10,488. So Bob would have to work at a minimum of 15 years to cover the costs of the program. So I know I didn't write out all the rest of the values, but if you somehow do this on your own time and get a number greater than 10,488 after 15 periods, just send me an email and I can explain the numbers I got to you, but that should be correct. But we can see for Billy and Bob that they each have to work a different amount of, a widely different amount of years to cover the costs based on these incremental earnings and how they're discounted. And that was all of number 4. So that's all the problems for today. But I accidentally made a mistake and forgot to do the second half of problem 1. So I'm going to go back and do that because it asks to calculate the internal rate of return, which is a very important concept that you've learned about that definitely I should go over. So the internal rate of return is the discount rate at which the present value of human capital investment will be 0. So it's like the break-even point where the person is indifferent between options. So in all these problems, we've been calculating like the net present value needs to be greater than 0, needs to be greater than 0, or we're deciding based on if something is positive or negative. In this case, it's finding a discount rate R that makes the present values equal to 0. And then if we're looking at 2 different options, we're finding the R that makes both of them equal to each other that would make a person indifferent in choosing them. So going back to number 1, we had already set up our equations. This was the one where the first period wasn't discounted since we were talking about their current costs. So this was number 1, part 2. So we had the 2 different present value equations based on if they were going to work or if they were going to school. So all we have to do is set the 2 equal to each other and then solve for R. So the first present value equation we had was 200 plus 250 over 1 plus R, and that equals negative 100 plus 575 over 1 plus R. So again, finding this R value is going to make these 2 present values equal to each other, and having them equal to each other would make the person indifferent in choosing one option over another. So then adding 100 both sides, we get 300 equals, then subtracting the 250 over 1 plus R from both sides. Since these 2 are the same denominator, we can just subtract the numerators. So we get 325 over 1 plus R. And then what I like doing to solve for this is cross multiplying. So I put it as 300 over 1. So these 2 get multiplied, so that gives us 325 on the left. And then these 2 get multiplied, so we get 300 times 1 plus R on the right. And then I'll distribute this out to get 300 plus 300R. Subtracting 300 from both sides, we get 25 equals 300R. So then we can see that the R is going to be 0.083, which translates to a discount rate of 8.3%. So this rate we just found, if we use this discount rate in the problem, these net present values would each come out to the same number, and it would make the person indifferent between the two options. Again, I'm sorry I accidentally skipped that, but I thought it was important to go back over. But internal rate of return is just the break-even point where the person's indifferent between two options, or where an investment would equal 0. So again, all these problems had a lot to do with net present value. There was a little bit of graphing, but I think we'll be using net present value a lot in future lessons, so it's important to understand now so you don't get lost later. So I would really focus on understanding how to do these problems and know how to set them up and what each of the different terms mean, because it isn't going away anytime soon. So that's all for today, but best of luck with your studying.